Right, section 4 is going to be about simplifying our rational expressions. So again, this is basically just simplifying our fractions. Now, if there's multiplication, then you can just cancel as usual. So cancel out or reduce down things on top and on bottom. And that works for both variables and the coefficients. If there's adding or subtracting, you have to factor first, then you can cancel things out. So let's look at what how that plays out in some of our examples. If we have 42k over 56k squared. Well, we can break those two things down. 42 is 6 times 7 times a k, so 6 times 7 times k. 56k squared is 7 times 8 times k times k. Now notice, 7 will cancel with 7, or they divide out. We're taking 7 out of both the numerator and denominator. We can also do that with one of our k's. After those canceling or dividing those out, we have a 6 over 8k. Now, we could be done at this point, except for the fact that 6 can be broken into 2 times 3, and 8 can be broken into 2 times 4, and we can cancel out 2 from each of those. When we do that, that leaves 3 over 4k. So this would be the most simplified form of this rational expression. Let's look at another one. 45n squared over 90n. So again, we can break it down. 45 is 5 times 9. N squared is an nn, n times n. 90 is 9 times 10 with an n there. Cancel out one n, 9 and 9. What are we left over with? Oops. 5n over 10. Again, 5 we cancel out, leave 1. 10 we cancel out, have 2. We're dividing 5 out of both of those. So again, if you want to see what that looks like, it's 2 times 5, and we're crossing out the 5, crossing out the 5. So instead of having to say 1n, we can just say n, and it's not over 10 anymore, it's over 2. N stayed on top, this 2 is what's now on bottom. So n over 2. That's just the simplified form of this rational expression. 10m squared plus 12m all over 20m cubed. This is a case because there's adding here, where we're going to have to factor first. This whole thing, we can take 2m out of each of these terms. Because if we were to distribute it, 2m times 5m, 2 times 5 is 10, m times m is m squared. So we can take the 2m out of this term. We can also take it out of this term, because 2m times 6 is 12m. So I took 2m out of these two pieces, so this factor came on the outside, and this factor is what stayed on the inside, this 5m plus 6. Now when you factor things out like this, you have to treat this whole thing in parentheses as though it was one number. This is one whole piece, and this 2m is a second piece. But 2m we can actually separate into 2 times m. So I'm going to put these a little closer together, because that's what 2m means. It's 2 times m. On bottom, we've got 20 times m times m times m. Now I'm going to break this down even a little more. This is 2 times 10. That's how we get a 20. This will make it a lot easier now to start canceling things out. Because we think of this as one number when it's in these parentheses, we can't cancel it out with anything on bottom. Even though we see m and m, we can't cancel those out because when it's in the parentheses, it's one number. So we can only cancel things out that match up exactly, like the 2 and the 2, the m and the m. So this number, 5m plus 6, stays on top. 10 times m stays on bottom. So we get 5m plus 6 over 10m squared. This would be our simplified form. X plus 3 over 7x squared plus 27x plus 18. This one's going to be a little more tricky. We're going to have to use that AC method of factoring from our last unit, or last lesson. So this is a trinomial. A, B, and C. These are the values from that trinomial, a, b, and c. We're going to use those to factor it. AC method says do a times c, so 7 times 18 makes 126. So now we need to find the factors, or what two things will multiply to 126. And here's a list of them. We're trying to find the ones that will add up to 27. Because 18 is positive, or should I say 126, 7 times 18, made a positive number. Either these are both positive or they're both negative. Now they both have to be positive because this one is positive. So here's a list of all of the numbers that would multiply to 126. 1 times 126, 2 times 63, 3 times 42, 6 times 21, 7 times 18, and 9 times 14. Which set would add up to this 27? Well, that's going to be 6 and 21. Those ones will add to 27. So we break down this trinomial, the 3 pieces, into 4 pieces. Instead of 27x, it's 6x plus 21x. Now once we've broken it up into 4 different pieces, we can factor by grouping. These two, we can take x out. These two, we can take 3 out. Notice in each case there's 7x plus 6 and 7x plus 6. Here it's times x, here it's times 3. So our factors are going to be 7x plus 6. That's all one number, one thing, because it's in the parentheses. And x plus 3. That's considered one number, or one factor, because it's in the parentheses. So the top piece stayed the same. Our numerator was x plus 3, so we still have x plus 3. Our denominator we could factor into 7x plus 6 and an x plus 3. Here's the fun part. X plus 3 was in both cases, so we can cancel it out. When you do that, that's the same as doing like 3 over 12 and calling 12 3 times 4. So we cancel that and cancel that. It's not 0 over 4. It's like there's a 1 there, so it's 1/4. 3 over 12 becomes 1/4. So if we cancel these out, we have to pretend there's a hidden like times 1 here. It's this times 1. So the 1 is what stays on top. And the bottom is still that, oops, click on that, 7x plus 6. This would be your simplified form. Oops, this is your simplified rational expression. Look at another example then. 21n squared minus 49n all over 49n squared minus 7n. Again, we're going to have to factor both pieces now. There's a minus in between these ones, so we take out whatever we can. Recognizing that these are not going to be trinomials, we can't do our AC method, but we can always try to take a greatest common factor out first. So what's the biggest number or the biggest piece we can take out of everything on top? Well, we can take 7n out. When we do that, 7n times 3n would give us this 21n squared. 7n times negative 7 gives us this negative 49n. So these are our two pieces, or our two factors. Same thing down here, 49n squared minus 7n. What can we take out of both of those? Well, 7 comes out of both of those numbers, and we can take n out of both of these variables. So 7n times 7n minus 1. So here is our factored form of the equation, or of the rational expression. And now we just cancel out our pieces to simplify it. 7n matches with 7n. We can cancel those out. This is considered one number. This is considered one number, and they're not the same as each other, so we can't cancel them. So those are going to be what's left over. 3n minus 7 over 7n minus 1. All right, we've got one more example here. We've got a squared plus 9a minus 10 all over a squared plus 2a minus 80. Again, always first check for greatest common factor as we factor these out. There is no greatest common factor on the top or the bottom, so since each of them have 3 terms, we have to do the AC method. This one, our a value is 1, our c is negative 10, so a times c is negative 10. This one, our a is 1, and our c is negative 80, so our AC value is negative 80. Here's a list then of all the numbers that would multiply to 10. 1 and 10, 2 and 5. And because this is a negative 10, we know one of these is going to be negative, one of them is going to be positive, and they have to add up to positive 9. The only set that would do that is if we had negative 1 and positive 10. Those will add to positive 9. So those are the ones we're going to use. Here's the list of numbers that would multiply to 80. 1 and 80, 2 and 40, 4 and 20, 5 and 16, 8 and 10. Okay, these are all of the sets that will multiply up to 80. Again, 80 is negative, so one of these is negative, one of them is positive. Which set has one negative and one positive and adds to a positive 2? Well, that would be negative 8 and positive 10. So, now that we know our two sets, we can break them down. This top one, instead of a squared plus 9a minus 10, became a squared minus 1a plus 10a minus 10. Factored those by grouping. Take the a out, leaves a minus 1. Take the 10 out, leaves a minus 1. So our two factors are a minus 1 and a plus 10. Looking at this bottom one, the one with the 80, we'll change it first to a squared minus 8a plus 10a minus 80. So we broke this into 4 terms. Factor by grouping, so out of these two we can take a, and it leaves a minus 8. Out of these two we can take out a 10, and it leaves a minus 8. Putting everything together then, the factors would be a minus 8 and a plus 10. So, using these numbers, this is the factored form of the top, this is the factored form of the bottom. So this is what our rational expression would simplify to. Or at least this is what it would factor to. Now that we have it in its factored form, a plus 10 crosses out with an a plus 10. These can only cancel because they're the exact same factor, a plus 10, a plus 10. You're thinking of that as one number because it's in the parentheses. So those ones will cancel out. A minus 1, a minus 8, those do not match. So those are what's left over. A minus 1 over a minus 8. That is the simplified version or the simplified form of this rational expression. And that'll wrap up our lesson.